Hello. Welcome to another edition of Office Hours. My name is Sohan Maheshwar. I'm a dev advocate here at OpZ. And today we're going to be talking about an experimental feature in SpiceDB called the Query Planner. And this is very exciting. It was just launched, I think, a couple of months ago. And we have a couple of folks from our open source team, which is Tanner and Barak here to discuss this. We've had Tanner on the show before, I think a couple of times, Tanner, but this is Barak's first appearance. So, Barak, welcome.
Thank you. Hi. Yeah.
Yeah. Yeah, and folks, if you like geeky computer sciencey algebra and other such related things, you might want to stick around for this. It's office hours format, so feel free to ask questions, put chats in the comments, and so on. And we'll try and get to all the comments that actually come through. Tanner, Barak, first of all, welcome. Maybe let's give a quick introduction about what we're talking about, and then we'll jump straight in.
Sure. So this is something that's kind of been a long time coming, and is something that Barak has been really excited about for a long time.
Yeah, it's been on my
10
mind a lot.
years.
Well, I mean, I've been thinking about these sorts of things for a long time. Yeah.
Yeah. But yeah, so we just want to talk about kind of how we got to needing a query plan or query planner, and then sort of how, what is a query plan? How does a query planner work? How does it work in SpiceDB specifically? So yeah, we can hop into it. Got some slides. So what is in a query plan? A little history of performance. It's been a year and a half since we pushed 1 million QPS through a SpiceDB cluster. This performance has always been like a bread and butter part of SpiceDB and how we develop SpiceDB. But there's also ways, and we've made a lot of optimizations to SpiceDB to get us to this place. Some examples are parallelization. So if there's a place where we can kind of look at multiple branches of the tree simultaneously and work on those results in parallel, we do. There's short circuiting. So here's two examples of a permission, like one with a union, one with an intersection. In the union case...
Can you tell us what they do, the union and intersection?
Sure. So in a permission, the union and intersection operators are basically saying, let's look at the set of things on the left and the set of things on the right, and then consider them together. So the way that you would read this top permission is the edit permission is there an editor relation? Or is there an editor relationship, or is there a viewer relationship? Is the union of these two sets non-empty? And so
there should probably be a view relationship now that I think about it. Because if you have, say you have a permission on a document to view this document, we want to make sure that you're either a viewer, which means you have read-only access, or you're a editor, which means you have read-only access as well as being able to edit.
Yep. From the performance perspective, though, the idea is that if you have one or the other, then you have the union, by the definition of a union. And so if we find one or the other, regardless of which one comes first, we can say, okay, cool, we've got an answer, and we're going to stop looking. We're going to cancel the other work that we were doing and return early. And we have a similar thing in the negative with intersections. So say there's a permission delete. It's defined as you have to be an admin in the system, and you also have to be an owner of the object. To answer this question, you're considering both parts of it, but the insight is that if you know that there does not exist an owner relationship, then it doesn't matter whether there's an admin relationship or not, because the intersection of an empty set with anything else is still the empty set. So if we determine that no, a user does not have the owner relationship, then we can return early and short circuit. And this is something that can speed things up a lot. We also have schema caching. So the picture is that on the left is the work that SpiceDB is doing to walk through your schema, and on the right is it fetching the schema so that it knows which paths it needs to walk. And in the naive case, each time that SpiceDB receives a request, it would go and look up the schema at that revision, look for all of the definitions that it needs to answer the question, and then like proceed with the walk. But we found that caching the schema at those revisions speeds things up quite a lot. If you're using the experimental watching schema cache, this is what I'm referring to here. So these are just some examples of optimizations that we've done already. But there's still places where SpiceDB behaves badly. And this is just down to essentially SpiceDB doesn't know where it's going. And so it's doing its best to like search for the answer each time that you're making a permissions check, but it's still having to look down every path to understand the answer. And this is where the idea of a query planner comes in. And I'll hand it over to Barak to talk about how we, how check permission works today, and then how we would construct a query plan that would do things better.
Yeah. So starting with the idea of like how, let's start with a very simple schema here, where we've got documents. Documents have direct editors, so you have been given exclusive edit access. But otherwise, it's viewable to a group. And the only way an editor could be possible for this is being part of that group. So you must have, in order to edit a document, like we're sharing this on Google Docs, something like that, you have to be able to both to view it. So you have to be a member of the groups that own it, and you have to be an editor. And so how do we check that? And today we do it like Tanner was saying. We might have, we might choose the, we don't necessarily know where it's going. Is really what it's saying is we're not planning ahead on our map. And we're thinking about this in terms of a map. We're trying to get to this destination. How are we going to get there? And so to check edit, first we check to see, okay, view, and we check the groups for that view, and then we think there might be multiple groups, and we check each group for its members and see if, say, Alice, who we're checking for this permission, is in that set. And then we check to see if Alice is an editor. Next slide. But that's already a little problem, right? If you think about that for a second, wouldn't it be easier if there's way few editors? Why don't we check editor first? Is Alice an editor? She can only possibly be an editor if she's got this relationship, before we do the work of going through the groups and through to see the group members. So we can short circuit, like Tanner was saying early, by checking this first. But because of the ordering as it's written in the schema, we don't know to check that first. In fact, in general, you're not sure which is the more profitable, in some sense, path to take first. So next slide. I'll pause there for like, does that kind of motivate why we're trying to get there?
Yeah, that makes sense. It's almost like we don't know the shape of what we are going into, right?
And importantly, we don't know the shape of the data either. The schema doesn't tell us how many editors there are. It doesn't tell us how many groups there are or how many users there are. If there's just a few, then it really doesn't matter. But if there's a lot on one side and very few on the other, then there's actually some work that can be done or saved. Yeah. So for instance, in a query plan, and this is a very light version of a query plan, you'll see some actual query plans here in a second. Intersection commutes, right? We have this intersection operation, which is the edit, view, and editor. On the left, we have the work, which is looking through the arrow, which is the view, group to member. And on the right side of this intersection, or the and operation in some sense, right? In Python, you see that view and editor. So we can rewrite that as editor and view at any time. And so the trick, right, is knowing when to make this change, which is in the next slide, which is to say, boop, we want to just rewrite, flip left and right for the intersection. Now we check the editor first, and then we check the arrow. And that's the kind of trick we're doing, right? So we're taking these trees and we're rebalancing them, or we're shifting them around, and doing other, work on these, query plans to make them more efficient. And that's kind of the goal.
Okay. And in the past, do you think people did this like manually? For instance, like I was writing a program and I'm like, okay, I have like 3 editors, but like millions of viewers. So I'm just going to design my schema this way and, not worry about anything else.
For our schemas, in some cases, like very more extreme cases of this, people have just rewritten specifically to kind of get this behavior going. But those cases have been fairly, I wouldn't say rare, but unusual.
Yeah, but it is concrete advice that we have given to users in the past to like reorder their intersection declaration if you know that there are more of one relationship than another.
And in general, and in most databases, you don't have to worry about this because for exactly this reason, which is the database will figure out the query, its plan ahead of time. And it's just something we haven't invested the time into until now. Next slide. Yeah. So yeah, making these sorts of flips depends on, like I was saying, the shape of the data, right? There's a lot of one thing and very few of the other. That's kind of the gist of a lot of these sort of statistics. What heuristics can we apply to direct the shape of what's going on is also kind of an important question. In this case, we're talking about just cardinality. We're talking about total number of written relations. We just know there are more groups than there are admin links, and that's it. So that's one guide we can use. Next slide. But we can do better. There's always more cowbell. Yeah. So there's another example we're going to talk about today, which is arrows. And so arrows don't commute, right? Like it's hard within the arrow. I can't just flip those two because it has meaning. It has a direction.
Barak, sorry to interrupt you, but can you tell the audience maybe what like an arrow does in the case of SpiceDB?
So the arrow is taking a relationship from the document to the group, and then following that group from the group to its members. So this document's been shared with engineering, and engineering has 10 people on the team. Then that's a relationship between the document and engineering to the members of that group. So because of that, it has a direction. I can't say, find me it doesn't make sense to even say, what is, tell me the members of this document when the document doesn't even have members to it, right? It only has groups that can do it. So I cannot reorder that. But, and this is the next slide, we can think about how we're gonna evaluate this, right? Which is we start with some document, we find all the groups that can see this document, and then we check to see that group if Alice is one of these members of this group. So we can, we have this evaluation strategy, which is to do it kind of in this forward direction, which is what we always do, by the way. Currently in SpiceDB, it's always forward. And so we kind of do this logical check. But if we hit the next slide, we can do something different. We could go backwards, right? Instead of starting from the document and asking, can Alice see this document through this arrow? We start with Alice and we say, what documents can she see? And so we find all the groups instead that Alice is a member of, and we see if that document is visible to any of those groups. Now, next slide, I think, is probably the right one for yeah. When do we make that decision, right? When would one be better than the other? And that's a question also about data shape. But the data shape in this case is sort of what we call the width of an arrow, or a fan out is another term you'll hear a lot, which is a trade-off between the questions of like, we want to go forward if, let's say, look at resources. So going from Alice backward is better if, say, Alice is a member of only 2 or 3 groups. The document might be widely shared. It might be public to engineering, marketing, all the other teams. But Alice is only in engineering. So going that way means I only have to check one group and see if that one group has it, as opposed to the other way around, which is saying if Alice is part of marketing, is Alice part of engineering, is Alice part of SRE, right? So there's less work to be done if you go that way. Conversely, if the document is not widely shared, it's only an engineering document. Or if Alice is in management, she might be part of lots of groups because she's doing lots of different, wearing lots of different hats. That's kind of the inverse situation that tells us to go one direction or the other. But we can't know that ahead of time, right? We can guess if we collect statistics, if we know something about the shape of the data. But we don't know when you write the schema which way to go. So and it's also fuzzy, right? Data can be in between. What if she's both? What if it is a widely shared document and she's in management, right? It could be both. These situations are not cut and dried. And there's a third one, but we won't go to that today. If you have a good idea, if you're in the chat, and you see it, then let us know.
That's for the folks in the comments.
Yeah, exactly. Get in the comments. Okay. Next slide. So let's see. Yeah, so if we want to optimize it, we use a different strategy for the arrow. But doing lookup resources as opposed to going forward or backwards on this arrow, lookup resource is going backward, just like the lookup resources call on SpiceDB. And so then we can say, okay, we want to first check that she's an editor if at all, and then work backwards and see if she is an editor, does she have also this view permission?
I have a question here, and good chance you'll probably talk about it later, so we can get to it then. But from using SpiceDB, right? Like a lookup resources call, I think is a little computationally more expensive than say like a check permission call. Typically, again, it depends. So again, is that like another runtime type decision on, okay, there's this huge, like set of documents and users, whatever. So a lookup resource is going to be like super extensive or, very expensive computationally. So should we do that to decide the shape?
Yeah. So something to clarify there is that when we're talking about the strategy being lookup resources, we're not talking about doing a lookup resources from Alice, the subject, all the way down to document. We're talking about in the intermediate hops that the arrow is doing. So it's like looking up the groups that Alice is a part of, and then below that we're doing checks against the document to those groups, or we're doing subjects from the document to find the groups, and then we're doing checks from those groups to Alice. So yeah, we're not talking about like the full tree, we're talking about just the part of the tree that's immediately around the arrow.
Understood. Okay.
Yeah,
that makes sense.
Because when you think about it, all these different lookup resources is very much like a check, except for it's a check where we're checking a very large set, right? We're trying to extract all the possible documents, and so we can use literally the same methods on in the query tree sense to look at, like Tanner was saying, just the local sort of arrow part. We can say like, okay, give me just across this set, like let's find the groups. And that's equivalent to a lookup resources if it's a very small lookup resources. And so we're going to, and we have to do this anyway today. And so we're just choosing which way to go.
Understood. Okay.
Yeah, stop. I guess demo time was so we can also show about some of the benchmarks and how this actually looks and how you can kind of see it inside the code base today. That's kind of the idea for demo. But it's also a great time to stop for more questions about like how this thing works, why this works, all the different Lego pieces that go into it.
Yeah, I'd love to start the demo. And for folks watching, if you have any questions, drop it in the chat. We also get a lot of folks watching post the live stream itself. So, we'll get like questions on the YouTube. Do you want me to share your screen, Barak?
Sure.
There we go.
Yeah. Let me make sure I get the right screen up on my screen. There we go. And so let's see. Talk about too many screens running around. All right. So inside query benchmarks, kind of working on the same idea, we have written a number of benchmarks where we try and sort of simulate these situations. Where, for instance, and I'll even dive in a little bit deeper because why not? Package benchmarks, say wide arrow, right? So this is very similar to what we were just talking about, where we can look at the schema. In fact, it's very, very similar to what we were just talking about, where a viewer is someone who is either a direct viewer or, instead of and this time, but that's fine, a group member. And the group has users and so on. But the difference is we can sort of simulate this by saying, okay, we have, say, 1,000 users, 100 groups, and 10 files. So that means those 10 files are very widely shared. They have to touch a bunch of different people. So trying to see if a file is shared with the people means that that's probably less efficient than going the other way, which is saying because there's only 10 files, can this user see the file as opposed to the other way around? This file is shared with a bunch of users.
Got it. And completely unrelated, Barak, but any reason you chose the prime numbers there?
For like the primes are there and they're commented as such because then it's easy to make them not overlap, right? We can keep adding. So say I'm user 1, then I can keep adding 1. And eventually I'll loop back around and I can add 2. But because 2 isn't co-prime with primes, then I never hit the same one twice. That's why.
Nice. That's smart. Okay. Nice.
It's a cute little trick for the testing cases. So if we look at, for instance, the benchmarks, so the query benchmarks, package query, by the way, is where a lot of this work lives. If you are on the SpiceDB repo, it's open source. And we're going to compare the wide arrows, I'm going to actually put a caret here for a reason you'll understand in a second. And we'll just run the benchmarks locally, just kind of show kind of what's going on under the hood.
Yeah, and again, this benchmark is first running on without Query Planner and with Query Planner.
Oh, this is actually both Query Planners. I'll show the without Query Planner and with Query Planner in a second. But this is just within a query plan, and why sort of optimization in these steps like we're talking about, why we can get so much performance out of it. So we have query plan, but just plain, where we don't run any optimizations. We just have it do it kind of in the same style as what currently happens today. And you'll notice, for instance, that these are like we saw in the slide deck, where we've got the different operations kind of as this tree of operations here. It's either we have view access, which is just a quick data store lookup to see if they have direct view access, or there's some group that they're a member of, and then that membership has some other access. So these are the different points. These are the base relations that we're going to look at from the data store, but in what order and how, right? And so this arrow, you'll notice, is left to right is the LTR, what that means. And so we're going through the group into the member, but after we've looked at it and we look at the shape of the data, we collect some statistics, we can flip that arrow and just run it right to left. Same structure, you'll notice, but we've just made a different choice of optimization and how to do it. And the difference is staggering, because instead of taking, in this case, 787 micros, which is what it would take, I mean, this is all local, it's not going over any gRPC yet. It instead takes 60, right? That's a 11x, 12x better performance, because we have 11x, 12x fewer edges we're crossing, right? Because we went the other direction, right? Because there's so few documents, it's easy to just see if Alice can see the one, as opposed to the document having to iterate all through all the people who can see it.
Yeah, awesome.
And so this is true now without, kind of without loss of generality. You can do this again, right? Which is to say there's double wide in here for a reason. That's why I had the caret. Same idea, except for we add another layer to it, right? Which is a file now has an organization has a group, and a group has a user. So we can now make this even deeper. And these things do get fairly deep in practice with a number of our clients.
Yeah, and these are the instances where you need something like a query planner, right? Because it's deeply nested. In enterprise, you have like a whole bunch of files and users, etc. And these are things that are probably slowing, like a permission check or whatever.
Yeah, exactly. Then these can get, in real situations, these get ridiculous deep. And what's more is they can have different shapes depending on like the different layers of these things. So there might be just a couple organizations and lots of users, or there could be lots of documents and very few groups. Like the permutations of the different ways these can come out is staggering. So we do the same sorts of tricks with primes and so on.
Yeah.
But yeah, files have organizations. So it'd be like this file is shared with engineering. Engineering has an open source team, and the open source team has me as a member, say. And so if we do that again, double wide, well, that's what that caret was for. Same idea. I'll just run wide arrow without the caret, and so you'll see both show up. So there's the wide from before, and then double wide, which takes, what is that, 11 milliseconds versus 194. So that's 100x, right? Less work being done, because now, granted, it's shaped specifically to see that both of those are going to reverse. Mm-hmm. But maybe one will, maybe the other one won't. You can do it all the different ways, depending on the shape of the data.
Very trivial question back, but what unit is that? NS/ is that
nanoseconds operation? Yeah, that says that after running, this is just Go's benchmark tool, which is great. After running 6,200 copies of this query, like really quickly in quick succession, right? So running through all the logic of, I want to, check this, check these ends, go all the way to data store, all the way back through the entire tree. It takes 194 microseconds or 194,000 nanoseconds to do that once on average for the 6,000 some odd times tried.
And if you multiply those numbers together, you get roughly the length of time that you were running the benchmark.
Yep.
Got it.
Yeah. And so, 100x improvement by doing just less work is really nice.
Cool. Nice.
Yeah. And so then, because you asked, just to kind of finish the part of it, we can run memory wide arrow here. This is now going through all of it. Right. So then this is going to compare against two different types. This is how SpiceDB doing the same sort of trick, but only using the code paths that are currently the primary code paths today, versus the gRPC. Like, no, there's going to be a lot more overhead for this one because there's going to be overhead now. We have to actually serialize the queries and run them against the, run them through our gRPC, run them through dispatch, run them through caching, all the different things we do inside of SpiceDB. And then when we run this, it should just, did I do that? White arrow? Yeah, there we go. Dispatch being the current way that is done today, and query plan being the optimized version from the other screen. And already we're getting like 2x, 2.5 something improvement, right? Because that's because we can do the reversal of error, because we can make these decisions at runtime. So, and same trick with double wide if you care. But like, and these are all like live. You can run these tests yourself. You like go check out SpiceDB and run all the different versions of the test that we're currently working on. Some of them are slower, even that can happen because we could choose poorly, right? We could choose to make the wrong decision. Often not, but it depends on statistics, and that would be ultimately bugs. This is what we're kind of sussing out before we make it not experimental. Right. But that's kind of what we're working on today. So
yeah, very cool. And if folks just joined, this is how you can make faster permission checks with the Query Planner, which is still experimental in SpiceDB. And Tana, I think you'll briefly talk about how you can run it in SpiceDB soon.
Yep. Yeah. And just like as a high level summary of all of the stuff we just talked about, it's like the difference between running a maze, being able to see a map of the maze beforehand or not. So like SpiceDB is running a maze to figure out whether a particular permission exists or not. And right now it doesn't have a map. It's really fast at running the maze, but it doesn't have a map. And the thing that we're working on with Query Plan is the idea that you should be able to like look at a map of the maze and then come up with a plan, a like series of I'm going to go left, I'm going to go right, and then like that is the thing that should take me to the exit. And whether you find the exit or not is up to the particular query, but having a map means that you should be able to make your way through the maze a lot faster. So let's talk about how you can play around with it. I want to swap back to the other screen.
Yeah, I like that analogy too, Dana. It's very cool.
And it works too because it's just like a maze. You could make some wrong decisions in there. It's possible, right? So you need to know a little bit more about the maze or take some guesses. Otherwise, you're sitting there planning and actually solving the maze before you solve it. So it's all heuristics.
So the flag in question is the experimental query plan flag. If you want to use it as an environment variable, it's going to be all caps SpiceDB _ experimental _ query _ plan. And then it's a comma separated list of the endpoints that you want to drive using the query plan, which are check, LR, and LS. The things to keep in mind here are definitely treated as experimental. This is under active development. We're still we're finding bugs, we're finding optimizations, we're also continuing to flesh things out. Just now, Barak was working on the dispatch logic. So how do you take a query plan execution and split it up across the multiple nodes of SpiceDB so that you can take better advantage of caching, which is one of the core optimizations of SpiceDB. And so we're working on getting the query planner to the place where it can use that. So it's not prod ready yet, but we do encourage you to try it, especially if there are particular queries or particular features of your workload that feel pathological. Like it just feels like there should be some way to make this work faster. Why is it not working faster? We'd love to know what you find when you try it out. Which queries were most improved? What were the relevant data and schema features? Were there any places where things got slower or where things looked incorrect? We'd love if you get at us on Discord or open an issue on the SpiceDB repository. Something that's generally true about query planners, like you'll see this in something like Postgres, that occasionally the query plan makes the best guess with the information that it has, and that guess is entirely wrong for the particular data that you've got. We're expecting that this will also be a thing that happens in SpiceDB, because no query plan can work optimally for all cases.
Contact with the enemy.
Yeah, it's that no query plan can work optimally for every query in a finite amount of time. So we're making trade-offs, but ideally what you should see is that your workflow should get faster in general, your tail latencies should come down in general, and we're just going to be sanding off rough edges between now and getting this out for prime time.
Yeah, sounds good. And then I assume Discord is the best place to reach out if people have questions, improvements, that sort of thing.
Yeah, as far as like getting a quick answer to a question, or if you just want to like drop a line and let us know something that you found, that's a good place to do it. If you think you've found a bug or another issue, then like the SpiceDB issues interface is a good place to go. Same thing with like the SpiceDB discussion board. If there's something that like it would help to just, you know, paste a huge block of text of like, this is what's going on, this is my schema, this is my data, that kind of stuff. So yeah, let us know.
I have a bunch of questions, so I'm going to annoy you guys with that. Starting with one which I think could be relevant to what we were just talking about. So say I am using SpiceDB as a developer in whatever, like a dev environment and stuff, and I want to use this. What's the best way for me to actually benchmark something like this and look at metrics and stuff, and then either be like, hey, this query planner is amazing, or hey, this query planner absolutely sucks, or whatever, right?
Yeah, it really depends on what you have available to you in your environment. In my experience, the gold standard is traffic shadowing. If there is some way for you to like have a SpiceDB instance that is turned on with this flag alongside your like standard SpiceDB instance, and if you have some place in your infrastructure where you can like, you know, copy the traffic in both directions, and then you can compare results, that's ideal, because that's like the most realistic that you can get. Not everybody's infrastructure has those features. Certainly we didn't at my last job. So absent that, we recommend like whatever load testing tools are available in your environment. We use K6, which is like this Golang JavaScript hybrid put together by Grafana for our internal load tests. We do have an open source tool called Thumper that you can use to generate load. You basically define scenarios and scripts as YAML documents, and then you can go and like point those at a running SpiceDB instance. So if you could use, you know, get some sort of representative data with that and use the schema that you've got, especially again, if there's like particular queries that you know behave badly and you can reproduce like the general shape of the data, that can be a really good way to go. If you have a development environment that is also using SpiceDB, just turning it on there and seeing what happens, especially if you can like flip back and forth between them, and then you can compare the metrics between them. All of those are ways that you can get some ideas, get some confidence in the behavior of the query planner.
Yeah, sounds good. For folks, if you're just watching this, Tanner mentioned an open source tool that we have created at Offset called Thumper, which you can use for your load testing. Thumper, like SpiceDB, also named after something in Dune. So, you know, got to keep the Offset cinematic universe going. Barak, question for you. Which something you briefly touched upon. So the benchmarks you showed were actually running locally, right? Mm-hmm. So how does this change when you're actually running this in prod and you're making gRPC calls for like check permissions and stuff like that, right? And follow up to that is anything else that I have to think about when I'm making a gRPC call?
There shouldn't ideally, in this fact, this is literally what I'm working on this week, is making these gRPC calls and making sure that they are correct and fast. But so what you're seeing locally, and you'll notice, is that like, for instance, it was a good bit slower running through the gRPC path.
Should I?
The second benchmarks.
Yeah. I'm just going to share your screen.
Yeah, makes sense. Like, so, like here, for instance, the double wide, right, took 194 micros, and it took instead about double that, right, with all the overhead that goes into like doing part of the gRPC work. And so these benchmarks are, the first one is just the fastest possible version. This is really good for us when we're debugging like low level, like, are we doing extra allocations in the query plan? Like, we're trying to assess that very targeted things inside of a query plan itself versus
it's like the performance equivalent of a unit test.
Yeah, it's like, yeah, so this would be a performance equivalent unit test, and in fact, this lives inside of integration testing. The second one, which actually does a sort of a from the outside with all the moving parts part, again locally, but this time it's taking on another layer of abstraction. And then, of course, the next level up from that is running our load tests, right, where we actually do set up a cluster and we run it that way. So,
and you can see too, like in the output of this benchmark, you can see that, so dispatch 16 is the current SpiceDB logic, query plan 16 is the new one. And you can see that dispatch is a lot closer to the query planner with everything set up, because with that dispatch layer, you're also getting all of the caching behavior and all of the optimizations that have been implemented at that layer in SpiceDB as it currently stands. And those are the things that we're working on folding into the query planner behavior, and we're expecting to see that gap grow as we sort of iron out the details.
Gotcha. Okay, very cool. Yeah, last couple of questions from me, and Tanner, this one is to you. Are there shapes of data or schema where you're like, a query planner either is overkill or you wouldn't recommend, or is it a very like wide, like it depends completely on how your schema and data looks like?
That's an interesting question. We want to get to the place where it always makes sense to use the query planner. So I think the answer to your question would be the simplest possible schemas will see the least benefit from the query plan. And there is some overhead that the query plan brings, in the sense that because like SpiceDB is taking the time to look at the map, look at the schema, and come up with its best guess of the path, that's time that it's not running the maze. Whereas like SpiceDB as it currently stands is just charging into the maze immediately. And so if your maze is 2 turns and you're done, then like starting earlier is going to get there faster. We do expect that overhead is going to come down, especially as we get additional optimizations in place around making sure that the maps of the schema are cached such that SpiceDB can just go and grab one and then start running. But yeah, there's some overhead.
Got it. Okay. I like that. And last question to you, Barak, and I think Tanner covered a bit of it just now. I was about to ask you, what are the future sort of iterations or improvements planned from now? Because I know you're working on this and it's been a while, without, of course, revealing too much.
Yeah, but there's so many different optimizations you can start to think of once you get going. So in some sense, I keep saying this sort of internally, but it's like we've built a Lego set, right? With all these different operations we can do for a SpiceDB query. Some of them are just going to the data store, some of the arrows we were talking about, the unions and intersections, all these different building blocks that are really building, really we're building a version of relational algebra, but we can actually kind of work with these individual blocks and reorder them and do other things. So what also becomes very interesting is all the different ways we can modify the tree to do various optimizations that would currently be impossible. A simple but kind of funny example of this is, suppose that the user needs to be a admin of the group as well as a member of the group or something like that. And you see you had a group dash admin and a group arrow admin, group arrow member, and you need to be either or both. You can actually find the groups first and then do the intersection on the right hand side. Sort of like it's as if you could write parentheses around the right side of the arrow. You can do, there are these sort of deep optimizations like that. You can also do things like caveats, and when do we deal with caveats? Do we deal with them as soon as we pull them off the data store, or do we wait for a while so we can cache some of the sub results? There's obviously, like for our enterprise customers, there's like, when do we call to materialize? Can materialize just answer this portion of the tree, and we can replace this entire sub problem with just a call to materialize, or not, right? Or evaluate it ourselves because maybe it doesn't have it, or maybe in combination it can be used. Different choices of when to do sub problems. I mean, it's the Lego set of just being like, when do we like rebuild and restructure how we evaluate this query? And those all things, by the way, or a number of those sorts of optimizations live inside of package query opt. If you want to see some of the modifications we make to the tree today, they're pretty minimal today, but that's where a lot of interesting work will be going.
Got it. Yep. I'll try and link that in the chat. And meanwhile, I think Tana had a couple of things to also mention.
Oh yeah, just like, you were asking about additional optimizations. There's something I think is interesting is that there's like compile time optimizations versus query time optimizations. So like what we were talking about with which way you should evaluate an arrow and it depends on the data. That's what I'm talking about when I say query time optimizations. It's based on observations of the data and like what makes more sense to do in that context. Whereas a compile time optimization is something that you could get just by looking at the schema. We have the ability to like make a map of the schema and then like, it's like, oh, well, if we're going this way, but then we're coming right back, then why wouldn't we just not go there? Or like if we go this way and then this way, but there's a shortcut here, then why wouldn't we just take the shortcut? A lot of that comes down to applied set theory, which is fun. So we have an entire optimizer that our co-founder Jimmy recently added that is just around applying set theory identities. So the operations, when you have a set and you do something to it and you just get that set back, then like all of the other stuff that you're doing is work that you don't have to do because you can identify that like, oh, it's just this set. Or if you have the empty set and then you're doing a whole bunch of other stuff with it and you just get back the empty set, then it's like, okay, we know we really have no work that we need to do there. And so we can just like cut out entire branches of the schema walk that don't make sense in a particular context. There's the idea of like union and intersection reordering that we were talking about earlier. One that I think is really fun is an idea of arrow reassociation. So we talked about flipping the direction of an arrow, but reassociation is the idea that like if you have a schema path that is, it's going from the folder to, or the document to the folder to the group to the user, you've got like 3 links in this chain. It might make a difference whether you consider like, you could sort of think about collapsing the individual hops to just like, permission view is it's, let's look at the folder arrowed to the group, arrowed to the user. And then if you put parentheses in different places in that expression, it changes how the execution would go because it changes what part of the problem you're considering first. And there are different ways that you can place those parentheses that give you different performance characteristics, which I don't know. I'm a math geek, and that's the kind of thing that just absolutely tickles me.
For sure.
Yeah. And then a sort of side benefit that we ran into recently, I was doing some work in SpiceDB recently to make lookup resources recursion depth errors easier to debug. And then I was talking to Barak about like, okay, how do I like port all of this logic into the query planner? And Barak was like, I don't think we need to. I was like, wait, what, really? He was like, yeah, like the query planner, like because it knows where it's going and knows where it's been, it's never going to get stuck in a cycle. Like currently, SpiceDB is doing the equivalent of, all right, I'm going to take all of the lefts that I see and If you do that in the right shape of maze, you're just going to end up in a loop. And because the query planner has a map and it can see those loops, it's not going to get stuck in those ways. You may still hit a max recursion depth error depending on like your data structure. Like if you have a folder that is deeper than your recursion, or like if you have a nested folder structure that's deeper than your SpiceDB recursion depth limit, you're still going to get that error. But you're not going to get the error if somehow like a folder becomes its own parent some way, or like if you have a group that's a member of another group. Both of those are the kinds of things that would have tripped up SpiceDB without the query planner. But with the query planner, it's just going to be like, yeah, I got it.
And this, incidentally, in the code, and when I talked about the building blocks of being like unions and intersections and data store grabs, this is actually a building block which is recursion. And we notice when we kind of drop our breadcrumbs along the maze, to take the analogy a little farther, and when we see that we've hit the schema itself, right, then we can wrap that whole loop as we know this is a loop. We know, therefore, here are the boundaries of the loop, and we might still need to evaluate it maybe multiple times, but at least we won't come back to the same corner twice. So
very cool. Excellent. All right. I mean, that's all the questions I had. Any last thoughts? We haven't had too many questions from folks watching. I know we have few folks watching live, but no questions yet. That's cool. Yeah. Any last thoughts from y'all before we wind up? I think
for
the
me,
one
it's
I'm
just
going to
that
say
it's
is.
been.
Sorry, go ahead, Tanner.
I was just going to say that for me, it's that it's been a long time coming, and it's been slow and steady progress, and it feels like we're getting close, and it's really exciting.
Yeah, we're starting to actually measure things. We're starting to get some real numbers about how much better it can be, right? That's we got the sort of low-level benchmarks and so on that we're kind of building up and up. And as we see more performance on the low end, we'll see it on the top end too.
Nice. Yeah. I mean, to give the point of view of someone not directly working from it, I've been seeing the updates that Tanner, Barak, and Maria and folks in our open source team have been working on, sharing like these benchmarks and like these numbers that are absolutely staggering. And I'm like, yeah, this is very cool, like super cool stuff. So yeah, awesome stuff, guys. Just a couple of quick shout outs for people watching. SpiceDB is open source. It's on GitHub. If you have any, as Tanner and Barak mentioned, if you have any things, there are issues and pull requests, you can go ahead and create that. If you need any help, we're super active on Discord. So that's our Discord server. So jump in there and we'd love to hear from you. We do the stream every couple of weeks. A fortnight from now, I'll be streaming about the LangChain SpiceDB client library for adding fine-grained permissions in your AI applications like RAG and agents and whatnot. Barak, Tanner, thank you so much for this. Super cool again. And maybe we can do part 2 when we go fully live with the Query Planner.
Yeah, that'd be great.
Sounds good.
All right. See you, everyone. Bye.